The second part of our logarithm lesson is solving exponential equations. What does this have to do with logs? Well, we'll see in a second. As always in math, if you look on the box near the bottom of page 4, it's this. It says given b bigger than 0 and b not equal to 1. I don't know what's going on here. Not equal to 1. That's my focal point here. If b to the x equals b to the y, then x equals y. So we try to make this as complicated as we can. Basically, what's it saying here? So you see how these bases are the same? So if b is raised to the x power and b is raised to the y power, does it make sense that x has to be the same as y? Yeah. Think about it, doesn't it? So that's all the same. So when you look at example A here, where I get 7 to the 2x plus 1 equals 7 to the 3x minus 2, well, what can I conclude? Yeah, I wrote it. Exactly. So an exponential equation, I guess we should mention it, that's where the exponent, that's where your variable is in the exponent. That's what makes it an exponential equation. So if my bases are the same, just set those exponents equal. If I subtract 2x, I get an x here. If I add 2, I get a 3 there. Symmetric property of equality, x equals 3. And you can plug in a 3 in here, plug the 3 in here. You should get a 7 on both sides. We do. So I know I've got the right answer here. Makes sense. That just makes sense, right? I think it does. Now, if we look at this second one, now the bases are not the same. I've got 3 to 2x minus 1 equals 27 to the x. Not the same. Yes, ma'am. Well, that's a good thought. She said, why don't we just multiply this by 9? And that's a really good thought. So if we do this, just a second, let's just see. Because I love these ideas, and I don't care if they're right or wrong, really. I like that you're actually thinking about them. Let's see if it works. So think of the law of order of operations. What would you do first?
You would add.
You'd have to do this first, and then multiply the 9. So putting this 9 here does not give me a 27. But I like that thought. I mean, it's just, please don't feel bad when you kind of offer something like that, because if we're thinking of things. Yeah, what do you think, Madison?
If you multiply by 9, but between 9 times 3 and times 2.
Can I do that? Because she said, well, why don't we just take it out and do this? We'll just fool it. The issue is, I can't change what they give me. They are saying 3 is raised to this power. 3 is. And you can't just go and change it unless we've got some other way of handling it. But, okay, let's keep thinking. Like, we're broadening our ideas here. What do you think, Rohit?
You can multiply,
I would, and then it doesn't help me, right? It doesn't, like if I did one side by 9 and the other side by 9, I still don't have the 3 and the 27 matching. Because that order of operation says these are a team. They don't come apart. They just don't. Carrie, what do you think?
You raise it to a third if you cube one side.
Use one side. What do you mean by that?
Then how would it work?
What do you think, Rachel?
I'm not sure. We did 3 higher, 3 to the power of 2x minus 1 and 2 to the power of 10.
Yeah, that's what Jerry was going with, right?
Then you have to cube 27.
Yeah, right? If you cube one side, you got to cube the other. What do you think?
You do what you did in letter A, but then multiply the exponent from 3 by 9.
Ooh, I think we're getting a little closer here. She's saying, why don't we start thinking about the exponent? So, it's getting way closer. Let's focus on the 27. You guys are working on the 3. Think about the 27. Is there another way to express 27? What do you think? Divided by 9. I'm not looking for divide because I'm in exponents now. I'm with powers. Whoa, what do you think, Rachel? Sorta, yeah. 3 cubed. 27 equals 3 cubed, doesn't it? So why can I make this substitution? So I'm going to leave this one the same. Instead of writing 27, I'm going to write 3 cubed. And I'm going to raise that to the x power. That brainstorming session was fantastic, by the way. And I think everybody helped. With each kind of maybe not right answer, it led to more and more to kind of a way that would work. It was kind of amazing, actually. Now, what I did is I have a power to a power. What's that rule, multiply it. So again, this side I didn't change it, but what does this side become? 3 to the 3x. And now I kind of look like this now. I look like this. 3 to this power equals 3 to that power. So what can I say about those exponents? They are equal. Fantastic. And this, we can solve that, right? So subtract the 2x, that becomes x. And then symmetric property of equality. So it looks like x is -1. Fabulous. That was excellent. All right, now that we kind of have that thought, when I look at C, what can I do here? It's really helpful to have the same base. So, Rachel, what do you think?
Make the 25, 5, 2, 5 squared.
Yeah, let's make that substitution, because 25 is 5 squared, it matches that one. So that becomes 3x minus 8, right? That's the same. And this is 5 squared raised to the 2x power. But a power to a power, that's our multiply rule. So this side stays the same, and I'm getting 5 to the 4x. And now we have the same base, so I can set my exponents equal. 3x minus 8 equals 4x. These are all kind of easy ones, aren't they? Then subtract the 3x, there's an x. X equals -8. Wonderful. Oh, look at me. Guy. What can we do with that guy? What do you think, Thomas? Divided by 2? I mean, remember, they're glued together. They're an exponent. We can think about this in maybe 2 steps. What do you think, Rohit? Never mind. Intermediate step? Like a 2 and a 4. There is a relationship, right? When I'm thinking of squaring and stuff like that. 4 is 2 squared? I mean, does this help at all to make this a 2 squared x equals 1/2 x to the -3 and use my product rule? Now I'm getting 2 to the 2x equals 1/2 to the x minus 3. Deepti, what do you think?
You could make 1/2
4 to the -6?
Wait,
Whoa! Oh, -6, I was just 4 to the -6. Well, why did I make it down to 2's? I simplified it a little bit first because I thought if we're looking at this, it's absolutely on the right track. But now they're both 2's. So what can I do here? Yes, ma'am.
Make 1/2 and raise it to -1.
All right, let's see. If I take 1/2 and I raise it to the -1, what is that? 2? So if 2 is the same as 1/2 to the -1, see this 2 here? Instead of writing 2, can I write this? So I'm going to put a 1/2 to the -1 because you're telling me that's the same as 2. And then I'm going to raise that to 2x. And then this side stays the same. Right? That's a tricky one. Okay, now I can multiply this a power to a power once again. So I've got 1/2 to the -2x equals 1/2 to the x minus 3. Wow. And now I've got the same base. Let me finish it up here. That -2x is going to equal x minus 3. So let's see, how does that work? We're going to add that, subtracting x, right? So -3x equals -3x equals 1. Wowee. So there's a lot of work there. But we got there. So some of them are a little bit harder than others. But as long as we can get the basis the same, we can use this little rule here, this little theorem, I guess, where you can just set those exponents equal. Okay. Well, what if they can't get a common base? Okay? There is no common base. So like I'm looking here at 5x to the 7. Can a 5 and a 7, can we ever get them to have the same base, or at least easily?
No.
I can't think I can do that. So now here's why we learned about logarithms. One of the reasons we need logarithms. So we're going to solve this equation using logarithms. So here are the steps. Now this step, I'm putting a big giant star here because we had a big fail on this step when we did absolute value equations. A lot of people did not notice that you had to like isolate the absolute value so that it's the only thing on one side of the equal. Well, I'm going to say it again real loud. Look how loud I'm talking. You hear me? Yeah, okay.
Yes.
Isolate, thank you. Isolate the exponential expression. which means if you've got some kind of exponential expression and you're multiplying by 5 and you're subtracting 4 and it equals a number, don't do anything yet till you add 4 and divide by 5. So I want just this thing all by itself on one side of the equal. Do we have that? Yeah. By the way, if it's an absolute value, you have to do the same kind of thing, except it's an absolute value all by itself. Okay, so we're going to keep that in mind. Star, star, talk loud. You're going to take the log of both sides. You can take log base 10 or a natural log. You can take any log you want, but these are the ones on our calculator. And then you solve for the variable. Let's see what, okay. So if I have 5x equals 7, I'm going to take the log of both sides. And I tend to use natural log. You can use log base 10 or natural log. It doesn't matter. So ln of 5x equals ln of 7. Whatever you do to one side of your equation, right, you do to the other. Taking the log of both. Okay. So you all tell me you get all this expansion and whatever. So what can I do with this guy? Jerry, what can I do with this guy? What are those little rules we have? This x up here. Wait. Okay, so Christian, what's the next step? Yeah, we're going to move the x in front because that's our power rule, or power property with logs. And now I want to solve for x. Now remember, this is just a number. It's nothing mysterious. It's just a number. So you're going to divide by this number. And ln 5 over ln 5 is a 1. Just like anything divided by anything, as long as it's not 0, is 1. So this is the exact solution. It's ln 7 over ln 5. That's the exact solution. Now if you want an estimate, yeah, you go here. You skipped a lot of steps, so I just wanted to back it up a little bit. So ln 7, closest thing, by the way, if you're doing the divide in one step, don't forget to close that guy. ln 5, and it's approximately 1.21. Yes, sir. Okay, awesome. It said, look at this. I can rewrite this. This is really log base 5 of 7, and that's x, right? That's converting it. They said, well, I used the change of base formula. I said log of 7 over log of 5. Got the same thing. And that's what this is? Log of 7 over, we got there anyway. So we actually kind of almost proved to ourselves that this is just fine. Awesome. You can do it either way. No problem with that. Okay. Let's try this guy now. You can use the Christian method, but we're going to practice the, yeah, you didn't know that name. That's what it's called. So we're going to take log of both sides, or you can use your method, see if we get to the same place. So I'm going to take natural log of 3 to the 2x plus 1, and take the natural log of 15, take the log of both sides. If you're using LOG, that's fine too. Now this, using that power rule, is going to go up front. So 2x plus 1. Now this is a grouping. It's grouped together of times ln 3 equals ln 15. Divide by that ln 3. Okay. Now this is a linear equation. This is a scary looking number, but it is just a number. It's a number. So what do you do next? You subtract 1. I'm running out of room here. And I'm just subtracting this 1. And then what? Divide by 2. What gets divided by 2? Whole thing. So x is going to be, what's on this side now? This number, oops, minus 1, whole thing over 2. That's x. So if they wanted the exact answer, you know, here you go. But I want a number. Let's see if we can turn that into a number. Let's see. Okay, he's got one. Let's see if we get the same thing. So the ln 15 divided by ln 7. I'm going to hit enter now. Then I'm going to subtract 1. Did I make a mistake?
Yeah.
Oh, yes, 13. What am I writing? Let's try it again. Ln 15 divided by 13, right? Oh my gosh. Okay, I'm getting rid of this whole thing. All right, here I go. This one. And I'm going slowly. 3. Wow. What happened? Oh. And I propagated that. I didn't go slowly enough. Okay. That's right. Okay. Thanks, friends. All right, divided by 3. Now I can hit enter and subtract 1. And then I can divide by 2. 0.732-ish. Is that what you got using the Christian method? Yeah, we should do that. That's fine. Alright, this is messy now. Let's see what's going on here. Uh-oh. Oh, it's got this little fraction here. Is that a problem? You don't care, right? We're not afraid. And by the way, remember this one? That was kind of a pain. Could I have used the same method here? Yeah. You could even do it with the easy ones if you want to. You can. No big deal. So if you really just want to remember one thing, you can just remember this method. So this becomes, you can do it and see if we all get to the same place. Take the log of this side, you take the log of that side. The x goes up front. I'm going to get rid of some of my mess here. There is some of my mess. So then that's x times this guy equals ln 3. So x is going to be, now remember, this is just a number, so divide both sides by ln half. And let's see what we get, if I can type it in right this time. All right, do that by this one, divided by that one. Okay. Negative 1.58, approximately?
Yeah.
Now remember what we're finding here. What are you finding? 1/2 raised to this power is about 3. Right? You're actually solving an exponent in a different equation. Who's following? Anybody? Anybody with me? Who's not following? Who's not listening? You got a couple of hands, right? Okay. Wake it up, wake it up. Okay. I love this one. This is a great one. Okay, so e to the x equals 30. So I'm going to take natural log of both sides. This time, take natural log. Do not take log 10. Natural log. Why? Well, I'm going to put the x in front. Now, wait a second. What is natural log of e? Let me rewrite it as log base e of e. E to the what is e? 1. Yeah? So this x, here we go. Because this value, anytime you take a log with the same base of that thing, you get 1. So if you see an e to the x's, e is your base, use ln, don't use log. And by the same token, what if I had 10 to the x equals, I don't know, this number. What should I use here? Use log base 10. Because the same kind of thing is going to happen with something like this. The x comes in front. What is log base 10 of 10? 1. So it kind of disappears. So if you're using a base 10, use log base 10. If you have an e, use log base e. Anyway, ln 30, so I can just stick that right in here. No fuss, no muss, assuming I type it in right. 3.4-ish. And of course, using the Christian method, we could have said, well, that's easy. That's log base e of 30 is x. I could get there right away because that log base e is just ln. Yes, sir. Because the natural log of e is 1. Here's natural log of e. Let's remind ourselves it's log base e of e, right? E to the 1 power is e. Whenever these two things match, it's 1. Because you're taking this to that power. That's how you get the same number. Yeah? Okay, now this is who said like, oh, isolate the expression. So I'm going over to you ladies again, This is a case where I can't do anything till I add the 2 first. That's what I mean by isolate the exponential expression. This is the exponential expression right here. So you have to do that first. Don't take the log yet until you have it all by itself. Makes sense? Yeah. All right, so if I take the log, I'm going to take a little shortcut here. If I take the log of both sides, the x plus 2, again, it's grouped, times the natural log of 4 equals ln 4t. So x plus 2 is this thing, ln 14 over ln 4. And now if I want x by itself, I have to subtract 2 from both sides, right? So x is ln 14 over ln 4, whoops, minus 2. And now we got to do all this stuff here. And ln 14, close parentheses, divided by ln 4, I'm going to hit enter. And then I'm going to subtract 2. I'm getting negative, what did I get? 0.963, is that right? 0.0963. Negative, right? Negative, okay. Yes? This is easy peasy. Or is it? Questions? Okay, this one here is like, you know what I mean when I say this is like graduate level? Like if you're going for your PhD, that's this one. Still like really hard ones. Okay, this one's really hard. If you're like, please don't make this any harder, listen, nod your head, and go, okay. But this one is one I did with my tree class. So, they're advanced students. So let's see what happens here. E to the 2x minus 4 to the x plus 3. Oh, this thing here, this is an e to the x squared. This is an e to the x squared. There's something kind of wacky going on with this. So when you get ones kind of like this, you get good at kind of noticing it. I'm going to let y equal e to the x. So I'm going to have a little declaration. I'm going to set y equal to e to the x. And I'm going to substitute in here. Because y, this is e to the x squared. This becomes y squared minus 4y plus 3 equals 0 when I make this substitution. You'll see why in a second, why I made that substitution. Does this part make sense at all? Okay. Can you solve this by subtracting 3 and dividing by 4? How do you solve a quadratic? Let's factor it. You can factor it, right? So that's a y and that's a y. Two numbers multiply to 3, add to negative 4, minus 3, minus 1. So that means that y equals 3, or y equals 1, right? Except what's y? E to the x. So e to the x equals 3, or e to the x equals 1. So take the log of both sides, right? So if I take the ln, this says that x equals ln 3, because ln e is 1. And this says that x ln e equals 1. Wait, this one wrong? I'm messing up because I know this one's 0. This one x is 0 because I see it. I don't know what I did wrong there. But this one, it should be ln 1. Yeah, no, that's right. X equals ln 1, which is 0. That's why. So x equals 0, and then this x is whatever the ln of 3 is. 1, 3. Oh, 1.1-ish. So the solutions to this one are 1.1 and 0. Wow. So this one is like the super hard one. So I just want you to see it. I'm not going to ask you to be able to do that one. It's not going to be on the test. But some people want stuff a little bit harder. This is like the cool stuff. Yeah. All right, so I had e to the x equals 3. What, you got it? Right, solve these. But take the ln of both sides. All right, well, I'll do one of them. So x ln e equals ln 3, right? Taking the ln of both sides. The ln of e is 1, so x equals ln 3. So you get the same business over here. Of course, the ln of 1 is 0, but oh, there's a whole other story. Okay, that was a hard one, just for fun. It was cool. Okay, up to you, Trice. Give it a shot. Give it a go. My suggestion when you get to here, should you use ln or log? This one? Base 10, use log. It'll be easier. If it's base e, definitely use ln. That's my hint. I put the answers here in terms of the log. So these are exact ones. I can tell you what I got approximately. And then you'll really see if I have this right. You can compare this. Check my work. Let's put it that way. Check my work. Yeah, by isolating here, you would say minus 8, right? So 2 e to the x equals 4. You're not done isolating. See this 2? Divide by it. So now you're getting e to the x equals 2, and that's where the ln2 is coming from. Take the ln of both sides. It works. That's what I mean by isolate your exponents. Yeah. D. This one? E. Okay, so we have to isolate. So first thing you have to do is divide by the 6. So I'm getting 2 x plus 3 equals 5. Okay, I'm gonna take the log of both sides. So x plus 3, that kind of grouped together, times ln 2 equals ln 5. I'm going to divide by this number. Remember, it's just a number. So that means that x plus 3 equals ln 5 over ln 2. Want x by itself? Subtract by 3. So this number, whoops, wow, this is messy, minus 3. And that's this. Put this in your calculator, you should get there. All right, big. So first thing you do is subtract that guy. So 10 to the 3x plus 4 equals 5. I just did subtract that. So far so good? All right, so I'm going to take log base 10 of both sides. Working with log base 10. Wow, this is messy. Let me see if I can clear up the spot here. Okay, so really read this myself. So that means 3x plus 4 times the log base 10 of 10 equals log of 5. What is the log base 10 of 10? 1, right? Because there's a 10 here. 10 to what power is 10? 1. So now I've got 3x plus 4 equals the log of 5. Subtract 4. 3x equals log 5 minus 4, and divide the whole thing by 3, and that's where I got that. Yes, sir? Where am I? What? We're on a different question? Wait 1 second. Does that make sense? Yeah? Okay, what's your question on which one? Yeah?
You say log 6 plus log 2
No, because
That's not part of the
this is not part of it. If this was a parenthesis here, maybe, but this is outside. Remember your order of operations. This goes first, then this. You want to get rid of that. Yeah. So that's what I mean by isolate that guy. Move everything out of the way. Okay, how we do? Any more questions?